Hello, everyone. Let's go on. When discussing the conduction of G waves, we often use the term projection. While it effectively conveys the direction of G waves transmission, it carried a subtle ambiguity. The term might imply that the force driving the movement originates solely from the initial point of conduction. However, I want to clarify that projection merely denotes the direction of motion without necessarily attributing the force entirely to the source of the G waves. It's common belief that things move in the direction of least resistance or the resultant force. While these ideas have some validity, they are not entirely accurate. A more precise explanation is that an object's vector acceleration changes along the direction of the resultant force over time. However, this does immediately alter its motion. For instance, a braking car continues to move forward until it stops. Similarly, when a vector effect of G-wave computation leads one G-wave to prevail, it might not instantly change behavior. It could instead slow it down or decrease its frequency over time. What does this mean for applying G theory in real-world scenarios, such as therapy? When treating patients with excessive or impulsive behaviors, we can assess the effectiveness of interventions by observing changes in the speed or frequency of those behaviors. This approach helps maintain therapeutic confidence, even if the behaviors persist initially. Problematic behaviors often arise from strong stimuli that have been reinforced over time, creating high stable G structures. Reshaping these through non surgical interventions requires persistence and a long-term com- commitment. Returning to the concept of the attention zone, let's revisit the scholar example from chapter 25. As the scholar works while thinking about academic problems, the G waves in the attention zone are related to the problem at hand. Simultaneously, the scenery along the road projects sensory, sensory G waves to the broader G wave field. What we now call the non-focus zone. The non-focus zone still functions effectively. For instance, the sensory G waves from the surroundings enable the scholar to avoid obstacles like telephone poles. Similarly, when a striking woman with a prominent figure enters the scholar's field of vision, the non-focus zone transmits sensory G waves that activate the scholar's admiration for beauty, G. This activation results in a behavior, turning his head to look. Once the scholar's gaze focuses on the woman's chest. The content of his attention shifts fundamentally from academic problems to the woman's physical features. Why does this happen? Let's analyze. 1. The scholar is initially focused on his academic thoughts. 2. The visual derives from the woman's appearance activate the admiration for beauty G cluster. And this 3, at this point, two compelling G clusters exist. The academic G cluster and the admiration for beauty G cluster. 4. The sensory G waves generated by the visual input reinforce the activation of the admiration for beauty G cluster, which is already strong. 5. Following the vector dominance effect of G-wave competition, the stronger G cluster prevails. As a result, the scholar's attention shifts entirely to the woman's appearance, with attention G zone now dominated by G waves from the admiration for beauty cluster. If the passing woman were less attractive or lacked the physical traits that appeal to the scholar's admiration for beauty G, the activation wouldn't as strong. Similarly, if the scholar didn't have a strong inclination toward those traits, the admiration for beauty G would lose the competition, and his focus would remain on his academic thoughts. This raises an interesting question. Why don't less appealing stimuli activate the scholar's admiration for beauty G strongly? The answer lies in the baseline strength and activation potential of different G clusters. When the scholar gazes at the woman's physical features, his imagination often revolves around the current visual input. Even if thoughts or past encounters with similar stimuli arise, they immediately get compared to the present. If he becomes immersed in past memory, his gaze shifts away from the current sense. This phenomenon can also be explained through G theory. The scholar's eyes, as visual receptors, generate G waves corresponding to the current stimulus. These G waves form a crucial part of the admiration for beauty G cluster. When competing G waves arise from past memories, they undergo a vector competition process. The G waves with greater intensity, whether current or past, will dominate the scholar's attention zone, determining the focus of his thoughts and behavior. Okay, this chapter demonstrates how G theory reveals the intricate dynamics of attention shifts and competing stimuli in the brain. Whether analyzing therapeutic strategies or understanding everyday attention shifts, the computation between G waves play a critical role in shaping our behaviors and thoughts. So this is the content today. See you next time. Bye bye.